Hello, I'm Janice, and this is a video report summarizing the free Unity package project from Staffordshire University, module Advanced Mechanic Design. The video will be showcasing the mechanic feature, some research, theory, and explanation of method on how these mechanics were made, and finally will be self-reflection to analyze what's go well and what needs improvement in the package. So in this module, we were asked to build 3 different types of Unity package with 3 different types of mechanic: spline mesh generator, tank controller, and wave system. So the spline mesh generator does a job to render mesh when user using the spline tool. The video demonstrates using this tool, draw a spline, and the mesh will generate along the spline. Get reference from Unity spline tool. Next is to create a script that can reference the spline container in Unity scene. And based on the script, it will read the spline container, and Unity will draw out a mesh along the spline by looping over a set of vectors. The meaning of looping over vectors is to loop the vector's position along the spline, just like when you try to render a mesh in Unity by getting the vector's position of a cube. Every 2 vectors' position will link by a distance stroke, which is the width of the mesh we'll be generating. This combination is named resolution. By repeating the process, the mesh will be able to build along the spline. Between resolution, it will fill up the gaps, and this does the job to form the mesh. As the resolution value is adjusted, the mesh render will also change according to the change value. More resolution will build a detailed mesh, and less does the opposite. The yellow text displays the current position of the spline node, update the data as the user adjusted or make a change to it. The distance stroke was the main to control the mesh width by adjusting it. The width also could adjust it from a scale tool in the scene. A spline is a type of math calculation that ideally creates a sequence of points, which is the position and allows the control form of a shape. This gives user huge benefit to draw and edit the shape. A spline behind was controlled by a set of calculation of points and position, and this is a Bezier curve. To simplify it, it was running a calculation to add a t-value between 2 positions and lap distance continuously. Each t-value will be controlling points and give the ability controlling polygons. Since spline functioning requires a large amount of calculation, it also provides the benefit to create a smooth polygons we want to have. And this would be a huge benefit when combining spline and mesh generation together. By accessing a point in the spline container, 2 offset positions from the center of the spline node will be set, and this process will be repeated. These offset positions will be joined and construct a mesh which could be controlled by adjusting the value. The spline mesh generator does a good job on constructing and render mesh followed by the spline drawing and editing. Since the mesh construction script function as it got a reference of the spline container, which means it would be convenient for designers to access and use it. However, it also contains limits. If programmer wished to make some custom change on the spline itself, because it was not a custom spline script, it was taking reference of spline container in Unity engine, so it was impossible to custom it. In opposite, the mesh construction script is run under procedural geometry, so programmer or text scripter could easily access and make custom change to mesh construction. The data displayed on spline node position and mesh width provide an advantage to designer when using the generator. They could easily check the variables in the scene instead of checking from the engine inspector. The editor tool is giving designer a chance to adjust width of the mesh instead of adjusting it from inspector, which is hard to control the variables. But the editor tool could also include a shortcut like transform and rotation tool in Unity, which could benefit designer when they want fast editing. Tank control is about simulating a tank in real life, which is including calculation in physics, since it is a simulation of a tank control in a game. It's also including game user interface to inform user the current state of the tank. The tank would accelerate when the user activated acceleration input. The tank would slowly gain speed and drive along in a set of speed. Decelerating also does the same. The tank body will slightly slope once the tank accelerates or decelerates. The steering behavior is based on the tank mass, which impacting the turning and the driving speeds of the tank. Torque rotation is based on the camera control, which is a spring arm controlled by a cursor. When user moves the cursor, the camera will also move, and torque will follow along to rotate. Wheel suspension on the tank is aimed to stabilize the tank while driving. Therefore, the wheel will spring up and down when tank rolls over a slightly high obstacle. Shell and firing on the tank include physics on the shell weight. Therefore, the shell will be fired far, but also including the gravity. This is a Tiger tank, which is the tank model of the tank control simulation. By going over a tank structure, a tank basically requires engine powers to accelerate, suspension on wheels to roll over obstacle and remain stable, torque rotation speed to aim. Acceleration involves calculation of a tank engine horsepower, the tank speed, and the tank mass. After getting the numbers, then claim with a current speed to move the tank. It results as the user applies the input, it will give a constant speed to move the tank. Steering is a calculation of adding the opposite force to slow down the acceleration and turn the tank, but also keep the acceleration value. Therefore, it will be adding force into the wheel by the tank velocity to make the tank turns. Torque rotation links to the camera control by the cursor, but it only rotates in a set of transform, which require to use quarter-lean rotation to only move in sideways. As torque rotation change according to the camera, using quarter-leans could prevent gimbal lock, as it due to 3D rotation. Suspension on the tank is to stable the tank body when passing small obstacle. The theory behind suspension is the Hooke's law of a spring extension and compression force of vehicle's weight. By adding a damping in the spring, it will increase the traction and reduce the extension and compression of the vehicle and make it more stable. On the suspension, it does the move of stabilizing the tank, but also the wheel suspension was not too realistic compared with the Wolf tank game. This might require a further calculation on suspension physics. Tank speed up simulation is close to real-life vehicles when hitting on acceleration. However, the speed calculation does not reach a Tiger tank max speed, and the acceleration movement is slower than the Wolf tank models, which could affect the player's game feel on controlling. User interface in the scene provide information on the speed of the tank and update it as it moves. However, it can also include the steering angles to display the turns and the tank body facing directions, since torque rotation can sometimes mess up the control direction. The Wave system is run under a system in Unity engines, data-oriented technology stack. By scripting and setting the enemy spawner, the enemy components will continuously spawn until the simulation goal is reached. In this case, which would be the character Steph. The character is controllable on basic movement. It contains a rigid body with gravities, as is displayed in the video, of the characters trigger a box and fire a function to bounce. Enemy components could be destroyed when it collides with the attack components. Spawner spawn rate and time could be arranged to perform different stages of wave. Dots with the feature of entity component system give advantage in building wave system, as it is capable of coding a simulation containing a large number of entity components and runs smoothly with physics and behaviors. It is also capable of making custom change and control the complex situation. Job system in ECS could assign behaviors to overall components and performance, which could avoid the complexity of individual game object scripting and assigning. As it is separated into a system component and an entity, It would be convenient to apply and remove script without reassigning it or breaking the reference between script. Predicting the amount of data contained in a simulation. ECS contain a benefit to keep the simulation memory use and computer CPU level in the best performance. As wave system, it requires a large amount of spawning components. Therefore, ECS could do a great job on wave system when spawning enemies, to keep the simulation memories packed and remain the computer CPU performance high quality. ECS simple structure is benefit on prototyping, restrict for assign and scripting, since it can do debugging and editing in running time. Overall, the wave system is capable to spawn a set of prefab enemies, and when player collide with the spawned enemy entity, the simulation will stop. To make the wave system look more natural, adding in extra components with attack drop in the scene gives the simulation more interaction. When it collides with the spawned enemy, the enemy entity will be destroyed instead, and the simulation will keep running. This forms a game loop in the simulation to guide the player along until it hits the end of simulation. However, the lack of UI feedback in the scene could cause players to feel lost in the simulation. Therefore, adding spawn rate, time, and amount in the scene can help the player keep up the stage of the wave. Also, an attack tag object would be good if attached to a player to give the player more control in the simulation.